This is the story of average speed, instantaneous speed, and limits. Consider a falling object. A ball is dropped near the surface of the Earth, and we've defined it with s is equal to 16t squared, where distance is measured in feet and time in seconds. A natural question would be, what is the speed of the ball at time t is equal to 4? If you recall, we can find distance by multiplying rate and time. So would solving for rate in this formula be enough to find the speed of the ball? Unfortunately, this would be insufficient. This provides us average speed, but we want to know instantaneous speed. However, by using average speed, we can develop instantaneous speed with the help of calculus. Average speed tells us what happened over an interval of time, like a jogger whose position changes with time. Instantaneous speed tells us about something that happens so fast that no time elapses. So average speed in this scenario would give us an indeterminate form with no present defined value, so we need more development. We want to make a numerical observation, so we want to work around the intervals around 4. We want to take smaller and smaller intervals and notice any emerging patterns. If we take values on the right side of 4, such as 5, 4.1, and 4.01, we notice our average speed values are 144 feet per second, 129.6 feet per second, 128.16 feet per second. If we take values on the left side of 4, such as 3.5 and 3.99, we notice that the average speed values are 120 feet per second, 127.84 feet per second. So maybe we can take a guess and say that the instantaneous speed is 128 feet per second. Is this guess good enough? And of course it is not, because no matter how small the interval over which the average speed is calculated, the result is not at the instantaneous speed t is equal to 4. And again, we need more development. So what have we got so far? We have a falling object and we have average velocity or average speed, which we defined as the distance traveled over the elapsed time. Let us elevate this concept to an algebraic level by thinking more abstractly. So we will consider the closed interval 4, 4, and we will let h mean the increment of time. Let's find the average speed. By using this, we're able to calculate average speed and plugging in 4 plus h and 4 into our original function. In the end, we will result with average speed equaling 128 plus 16h. If we continue to let h become very small, or if we let h approach 0, then for our average velocity, 128 plus 16h will approach 128. So what does this mean? 128 is the limiting value of the average velocities as h approaches 0. So, using some notation, we can say that the limit of 128 plus 16h as h approaches 0 is 128. To recap, we saw how difficult it is to find the average velocity of the falling ball after 4 seconds because we are dealing with a single instant of time, t is equal to 4, so no time interval is involved. And as we shortened the period of time around 4, the average velocity became closer to 128. And when we approximated by using average speed and taking the interval 4, 4, we can take the limit of the average speed in order to find the instantaneous speed. So the instantaneous speed when t is equal to 4 is defined as the limiting value of the average speed over shorter and shorter intervals. 128 is the limiting value of the average velocities as h approaches 0. Thus, instantaneous speed is the limiting value of the average speeds. The instantaneous speed of the ball falling at t is equal to 4 is 128 feet per second. Whether we are finding average speed, instantaneous speed, or simply riding a bike or driving a car, we can rest assured that curiosity is all around us and calculus can help us understand the world around us a little better.